Welcome to BrightBoundX, where we explore the universe's most profound mysteries and challenge everything you thought you knew about our place in the cosmos. Today, we're tackling one of the most unsettling questions science has ever asked. What if humanity is the only advanced civilization in the entire universe? Think about it for a moment. Within billions of galaxies and countless trillions of planets, what if we are genuinely, cosmically alone? No neighbors, no signals, no second chances to find another intelligent species. But here's what makes this even more fascinating. A groundbreaking mathematical model suggests this isn't just philosophical speculation. It's statistically probable. So, what if the silence we hear from the stars isn't because no one is out there, but because we're trapped in what scientists call the Solitude Zone? This discovery challenges everything we believe about extraterrestrial life. Stick with us as we unpack this revolutionary hypothesis that might explain why, despite searching the cosmos for decades, humanity remains utterly isolated. Let's start with the numbers because they're staggering. Inside our Milky Way galaxy alone, there are approximately 100 to 200 billion stars. Around each star orbits an average of 1 to 2 planets. This gives us, conservatively, 100 to 400 billion habitable worlds in just one galaxy. Now, multiply that across the observable universe, which contains roughly 2 trillion galaxies. We're talking about quintillions of potentially habitable planets. By any mathematical standard, the probability of Earth being the only world to spawn intelligent life is infinitesimal. It defies logic. It defies odds. Yet here we stand in 2025, having sent radio signals into space for nearly a century. And what have we received? Silence. Absolute, deafening cosmic silence. This contradiction is known as the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" For decades, scientists proposed elaborate explanations. Perhaps intelligent life is vanishingly rare, or extraterrestrials have mastered the art of hiding, deliberately avoiding contact. Some theorize that advanced civilizations self-destruct before achieving spacefaring capability. But what if all these explanations miss the mark? What if there's a more elegant, mathematically elegant answer? Enter Dr. Antal Veres, Associate Professor of Mathematics at the University of Agriculture in Hungary. This is not a fringe theorist or science fiction author. This is a rigorous mathematician who approached the Fermi Paradox from an entirely new angle: pure probability. Rather than speculating about alien behavior or the rarity of life itself, Dr. Veres asked a fundamentally different question. Given what we know about complexity and civilization development, what does statistical probability actually tell us? His research doesn't dismiss previous theories. Instead, it adds a crucial layer of mathematical rigor that most extraterrestrial hypotheses have lacked. What makes Dr. Veres' work particularly compelling is its counterintuitive conclusion. The more advanced a civilization becomes, the more likely it is to be alone. This isn't pessimism. This is mathematics. And the numbers he calculated are stunning enough to warrant serious consideration from the scientific community. So, what exactly is the Solitude Zone that keeps appearing in Dr. Veres' research? Imagine the universe as a vast probability distribution. On one end, you have scenarios where intelligent life emerges constantly, everywhere civilization clustering like stars in a globular cluster. On the other end, you have the possibility of life emerging so rarely that humanity stands alone. The Solitude Zone is something in between a mathematical window, where the conditions create a unique outcome. Exactly one advanced civilization exists at any given time within an observable region of the cosmos. Think of it like a Goldilocks problem, but inverted. The conditions aren't just right for thriving life, they're precisely calibrated to produce isolation. Here's how it works. For simple life bacteria, microorganisms, the Solitude Zone doesn't really apply. Simple life should be common. The conditions for abiogenesis are likely abundant. But for advanced civilizations, beings with technology, culture, and the capability for spacefaring and mathematics shifts dramatically. In the Solitude Zone, the emergence conditions for intelligent life must be just frequent enough that life appears somewhere, but just rare enough that multiple advanced civilizations never coexist. It's like having exactly one golden ticket in a factory with billions of candy bars. The ticket exists, it had to be placed somewhere, and if you unwrap enough bars, you'll find it. But the odds of there being two golden tickets, astronomically low. This is where Dr. Veres' work becomes truly revolutionary. He didn't just propose a concept, he built a mathematical model with measurable variables. The model operates on two axes. The x-axis represents the probability of emergence. Essentially, how likely it is that a civilization of a given complexity level will spontaneously appear in the universe. Simple life. High probability. Photosynthetic organisms. Lower probability. 2. Using species. Even lower. Space-faring civilizations. Extremely low. The y-axis represents the probability of solitude, the statistical likelihood that only one civilization at that complexity level exists in the observable universe. Here's the revelation. These axes don't move independently. As complexity increases, something counterintuitive happens. The probability of solitude doesn't decrease, it increases. Why? Because the conditions that would allow one advanced civilization to emerge are so rare that allowing a second one to emerge simultaneously becomes exponentially more improbable. It's not that the universe is hostile to life. It's that the universe is stingy with advanced civilizations. According to Dr. Veres' calculations, humanity faces a 29.1% probability of existing in the Solitude Zone. Nearly 30% chance. That's not negligible. That's not a rounding error. That's a substantial statistical reality. Before you fall into existential despair, there's an important clarification. 29.1% is not the probability that we're definitely alone. It's the probability that if we're a humanity at a level of complexity, we're likely to be alone. This nuance matters enormously. Across all possible scenarios, varying assumptions about life's emergence rates, planetary habitability, and evolutionary pathways, Dr. Veres found that no single scenario produced a probability of solitude exceeding 50%. Even in the most pessimistic model, which researchers call the critical Earth scenario, where conditions for life are extraordinarily rare, the probability of humanity being alone topped out at 30.3%. What does this mean? Statistically speaking, the odds are still in our favor. If you had to place a bet, would you bet that humanity is the only advanced civilization in a universe of 2 trillion galaxies? Or would you bet that we have cosmic neighbors somewhere out there? The mathematics suggests the latter remains more probable. This is actually encouraging news for astrobiology and the search for extraterrestrial intelligence SETI. It means that while isolation is possible, it's not the default scenario. Somewhere out in the cosmos, there's still a better than even chance that another civilization is asking the same questions we are. For decades, the Fermi Paradox created a sense of cognitive dissonance. The math says life should be everywhere. Our observations say we're alone. Something had to give. Previous attempts to resolve this paradox range from the sobering to the strange. Maybe intelligent species always destroy themselves before achieving space travel, the Great Filter Hypothesis. Maybe aliens are out there, but deliberately hiding the zoo hypothesis. Maybe technology itself is unstable, and advanced civilizations collapse into primitivity. These theories often came with a dose of fatalism, or require assuming that extraterrestrials possess godlike capabilities to hide. Dr. Veres' Solitude Zone Hypothesis is elegant because it doesn't require any of these assumptions. It doesn't claim aliens are hiding. It doesn't assume self-destruction is inevitable. It simply acknowledges that rarity and isolation are mathematically compatible with the vastness of the universe. The paradox dissolves not because we've solved it, but because we've reframed it. The real question isn't why don't we see aliens? It's given the statistical rarity of complex civilizations, how often should we expect to see them? And the answer according to Veres's mathematics, is rarely. Perhaps never in our cosmic neighborhood, perhaps never in our lifetime. But rarely doesn't mean never. If the Solitude Zone Hypothesis is correct, it carries profound implications for how we view ourselves and our future. First, it redefines humanity's significance. We might not be alone because we're special. We might be alone because advanced civilizations are inherently rare. We're not the chosen species. We're the statistically improbable one. Second, it underscores the fragility of civilization. If the conditions for advanced life are rare, and if we're possibly the only advanced civilization observing a corner of the universe, then our civilization becomes irreplaceable in a cosmic context. Our survival, our achievements, our knowledge, these become unique not by design, but by accident of probability. Third, it reshapes our perspective on exploration and communication. Even if the probability of contact is low, the stakes of potential contact are incalculably high. A single confirmed signal would revolutionize everything. Fourth, it challenges us philosophically. If we're likely alone, then the universe's complexity, beauty, and mystery might only be appreciated by us. The cosmos might lack observers except for earthbound humanity. We become, in a very real sense, the universe's witnesses. This isn't isolation to be feared, it's responsibility to be embraced. The Solitude Zone Hypothesis is not the final word on the Fermi Paradox. Instead, it opens new avenues for investigation. Future research must grapple with harder questions. What are the true parameters for life's emergence? How do we measure the complexity threshold for a civilization? Are there other mathematical frameworks that produce different results? The hypothesis also invites experimental predictions. If Dr. Veres is correct, we should expect no signals from advanced civilizations in our current observation range. Possibly isolated evidence of simple life at distant locations. A universe that becomes less populated with advanced life the further we look. Mathematical consistency across multiple independent models. Scientists are already building upon this work, refining the probability calculations, and testing the model against observational data from exoplanet surveys and biosignature research. What's remarkable is that this hypothesis bridges the gap between pure mathematics and empirical astronomy. It's testable, it's falsifiable, it's science at its best. So the question isn't whether we'll ever confirm the Solitude Zone Hypothesis. The question is, what will we discover while searching for the answer? Thank you for joining us on this journey through one of astronomy's most mind-bending theories. The Solitude Zone Hypothesis reminds us that the universe is far stranger and far more mathematically elegant than we often give it credit for. But your perspective matters. Do you find the Solitude Zone concept convincing? Or do you believe the universe is teeming with hidden civilizations we simply haven't found yet? Share your thoughts in the comments below. Engage with this community of curious minds exploring the cosmos together. If this video challenged your thinking or expanded your perspective on humanity's place in the universe, please like this video. Your support helps us continue bringing cutting-edge scientific research to millions of viewers worldwide. Share this video with friends, family, and fellow space enthusiasts. Let's expand the conversation about our cosmic isolation and what it means for our future. And most importantly, subscribe to BrightBoundX for more deep dives into the universe's greatest mysteries. New episodes every week, exploring the frontiers of science, physics, cosmology, and the profound questions that define human existence. The universe is waiting to be understood, and we're here to guide you through it. BrightBoundX, where curiosity meets cosmos. Subscribe now, and let's explore the infinite together.